This is part 3 of the Titanic notebook. In this section, we'll be establishing hypotheses and then going ahead and pre-processing the data. So first, we're going to be looking at the titles, and specifically, this is like Mr. and Miss, and we can get this off the name column. So we're going to be looking at the first 5 names to start here. These are the strings that we have. We have Browd, Mr. Owen Harris, Cummings, Lincoln, a variety of different names here. And our goal is going to be to extract everything that's before the period, because the period is what actually denotes like the title, right? So this Miss would be the title we want. We want this Mrs., we want this, and we want this Mr. So that's what we want to extract. We're going to use something called regex here. You can read about it at this link here, but the idea here is this piece of code here is going to help us get everything before a period. So with that, we can quickly run this line here, and we can use this to basically go through this column here. And then we are basically taking out this this string here. So this is what we're getting. Captain, Calm, Countess, Dawn. These are all the titles that we've extracted from the data set. And then we can look at that by basically building kind of like a pivot table that shows us the title and then whether it's female or male, and then get the counts on here. So as it makes sense, right? That Miss would be mostly female, and then Mr. would be obviously all male. And we're doing this for our training set here. And there's a little note here, it's a fun note here that young hair, which is this title here, is it's this title that's given to a young unmarried child of high ranking knight or nobility. So it's the lowest rank of nobility. So it's kind of a fun side note here. There's only one male who has that. So it's something kind of extra on here. We can do the same thing for the test set. Obviously the test set is smaller, so there's going to be less titles there. But we can see that some titles appear quite frequently, like Mr. and Miss, and some are quite rare, like Dr. and Miss, right? So next we're going to go through and we're going to basically clean up this. There's quite a range of different titles here, but a lot of these are kind of too rare to actually be useful. So we're going to go use the common titles like Miss, Mr., and Master. We're going to use these as part of our model. And then we're going to basically get rid of these kind of more rare and uncommon titles here. So what we're going to do is take these titles, Lady, Countess, Captain, Call, Don, and we're going to replace them with rare. So the column would just say rare if it has these titles here. And then what we're going to do is there's going to be some misspellings or things that are essentially the same. So this is MLLE. This is just Miss. MS is a shortcut for Miss. So we're going to replace that and then just have Miss. And then Madam is also just kind of like Miss as well. So we can just substitute that for here as well. So we're doing a variety of replacement functions here just to kind of clean up and reorganize our titles. Next, we're going to check, does title actually have an effect on survival? So we're going to quickly just check, we're going to basically group by the title and then check, the mean of the survival column, which is going to tell us, what is the average survival rate for this particular title. So, from this, it makes sense it was high. For Mr., for men, it was a little bit lower. For Miss, it's also higher. And then for rare, these kind of weird titles that are less common, it's lower. And it might be because there's less of them in the data set, or it might be because these people were not, as high ranking, so they were less likely to survive. Next, we can, visualize this in one sense like this, but we can also plot this out to make it a little bit more nicer for us to see. So we have the made it, which is the survived here, and then we have deceased, which is passed away. We could see the distribution of the different titles and their survival, and how if they survived or not, which side they're on. Okay. So next, we're going to do some categorical variable mapping. So the idea here is that all these titles were in just one column to start with. Now we want to split it up. So we're going to take each of these titles here and then put a 1 if this passenger here had that title. So each within, I guess, this span here, there should only be one, and then the rest should all be 0. So we quickly do that here with the get dummies method. And then next, we are going to be dropping the title. We don't need this column anymore because we've already used it, so we can drop it. And then we're just going to take a look at what the data looks like here. So we drop this column and we have these titles basically cleaned up and ready to go here. Next, we're going to map the sex to a number. So before it was the actual name, male or female, we can just use this dictionary to map, and we can put a 1 if it's male, a female, and a 0 if it's male. So we've done that right here. And then next, we're going to work with age. So age is a bit tricky because we actually have a lot of missing values, and there's different approaches. One approach is just to take the average of all the different passengers, and then put that value for the missing NA values. But that might not be the best because there's a lot of nuances, right? So we can actually do a bit better, and how we do that is going to be by breaking people up into their sex and their socioeconomic class, and then looking at the median age in that particular sex socioeconomic class pair, and then use that to estimate or predict the age for these for a person who belongs in this sex socioeconomic class pair. So we can basically build this array here. So this array here is going to help us basically keep track of what the median ages for each particular group. So the row here is going to be the sex. So the first row is male, the second row is female, and then the columns denote the socioeconomic class. So this first column here, this is the first class, second class, and the third class. So this code here is helping us basically go through, and for each entry here, we are calculating what is that median age. And we can see here, so this is for our training set. The median age for the male, which is the first row, first class is 40, and then so on. Right, so this is what we've done for the training set. We can use this to estimate the values for the age in the training set. We do the same thing for the test set. So we are going through, and then we are building this basic table of medians here, and using that to add it to and replace our null values in our training set and test set. Okay, so we have basically gone through and we have done that here. So I can quickly show you the code here, but the idea here is that we are looping through all these entries in this 2x3 grid here. We are filtering to basically whatever people belong in this are satisfied that criteria, which is that belong in that sex, have that socioeconomic class. And then from there, we will calculate the median and we will stick that value into our little table here. And then we will go here and we will basically take that value that we calculated and plug it into whenever we see that appear in the data set. All right, so next we'll be dealing with age. So we'll continue work dealing with age, and we'll be looking at breaking it into bands. So one thing, when you have something that has a big range, it might be easier to just take that range and break it into 5 equal space groups. That's what we've done here. We've taken age and we've divided into 5 groups with the pd.cut method. So we have the 5 bands here. The first band is basically from 0 to 16 years old, and then 16 to 32, and so on. And we can then group by the band and see what is the mean survival in that band. So as you can see here, the younger band has the higher survival rate, which makes sense. And then as you get very older, they were less likely to survive. Right? It's like close to 9% here, where this is 55%. Next, we're going to take a look at the distribution of the survival relative to age. So these are distributions. So the idea here is that we've defined this function above, but we can do here is show that for sex 0, which is male, this is the distribution of people that survive. So we see a high amount of survivals in the 20 to 30 range. It might just be because there was a lot of 20 to 30-year-olds, but it gives us some insight into what is the distribution that people who are younger tend to survive, whereas people who are older had a lower chance of survival. And then we can see that for both the male and the female. And it's interesting that it's kind of a similar shape, right? We see that the people who didn't survive tend to be always in this kind of range over here. And then it was sort of similar for the people who did survive, right? It was kind of in this range as well. All right, next we'll be taking these columns of the age and we'll be breaking it into our categories. So we created these bands, but we created bands, but now we're actually going to stick one number to this whole band. So everything between or less than 16 years old, we're going to give it a value of 0. Everything between 16 and 32, we're going to give a value of 1, and so on. So we basically create a new age column that is categorical, and it looks a little bit cleaner than having these kind of these values here, which is the bands, right? We want it to be something that's just a number, so we can quickly just build it and incorporate it into our model. And once we do that, we can go ahead and remove the age band. That's what we've done here. So now this is our up-to-date cleaned data set that we were working with. Next, we're going to look at the travel party size. So this is, again, the SIB, SP, and PARCH. We are going to go through and calculate family size, which is just, the sum of the siblings, spouses, and then your parents and children on board, plus 1 for yourself. And that's going to be a new column we're going to call family size. Then we can go look at our family size and see the survival rate for each family size. As you can see here, of course, younger people or smaller families tend to survive, have a higher survival rate, right? So here that if your family has a 4, you had a 72% survival rate. Okay. Next, we're going to basically make a plot similar to before. We're going to take the people who survived and people who didn't, and then plot out the different family sizes and see if there was a significant differences on both sides. As you can see here, there was, if you were by yourself, you had a high chance. It appears here that you had a high chance of, not making it. And it's interesting. It seems like if you were a family of 2, you're kind of equally on the do not survive or survive side. So what this means is that, whether you were in a family 2, 3, or 4, 5, 6, it actually didn't make a difference because it's kind of the same, right? Whether you survived or not. But if you're by yourself, it seems like that makes a big difference in whether you survived or not. So we're gonna keep the family size of 1, and we're not going to use the family size of 2 and greater. So we can quickly check here that the family size, if you were alone, which is family size of 1, if you were alone, you had a 50% chance of surviving. And then if you were not alone, you had 50% chance of surviving, and if you were alone, you had a 30% chance of surviving. So of course, this could be due to other factors, but we are going to consider that being alone is a useful factor to whether you survive or not, and we'll keep that. So we will bring that into our column. We have this column that says whether the person survived or not, and then we also have this column now is they alone or not. So next, we're going to do feature construction. This is whether we're going to now build some own features using the data. So one idea here is that we can combine our age and our class and use that to predict make a new column that's going to help us predict whether they survived or didn't. So we are using something interesting here. We're multiplying age and their class. So we've done that here. For example, 3 times 1 is 3, and so on. And then we have this new column here. And then we can, of course, group by this column and check their survival rate. So the survival rate for this column is, a lower value. The age class means that they have a higher survival rate, which makes sense, right? We see in the lower numbers here, it's much higher, and then we have a higher value age times class, you're less likely to survive. Okay, so that's how we can, build our own custom features there. This is next we're talking about the port of embark, so where they embarked from. So this is the route from Southampton to Cherbourg to Queensland, and then to their unfortunate destination over here in the middle of the Atlantic. The important thing to keep in mind is that we want to basically look at a variety of features about the data set. So which was the most frequent port of where they embarked from the most? Most came from Southampton, which is over here. Let's see. So there is some, NA values we saw for embark. There wasn't too many, but we're going to do a quick thing, and we're just going to say that the most frequent port is probably, if we don't know where they embark from, it's NA. Let's just put in the most frequent one, which is Southampton. So we're just going to replace the NAs with Southampton here. Okay, and then we're going to group by and take a look at where the survival rates are relative to where they embarked from. So obviously, it looks like in the last place, from Cherbourg, that had the highest survival rate. We can quickly plot that here, so we can check the deceased or made it, and we can see what is the difference between the two here. So it looks like there was much more who passed away from Southampton than from, for example, much more passed away from Southampton, right? Because the column here is larger. Okay, so again, we're going to be converting this to categorical variables. So the column before was just one column. Now we're going to split into 3 columns. So this is where they embarked from, and then they should have a 1 if they embarked here, or a 0 if they didn't embark from that port. Okay, and then we can now drop the embarked column. We don't need that anymore. We have this. Next, we're going to be working with a fair amount. So we're doing a quick replacement. So we're filling the NA values for the fair amount with the median. And then next, we're going to be checking the bands. So we're going to break into 4 equal size bands, which is over here. And then we're going to group by the fair band and then check what was the rate of survival. So it seems like the one who, if you pay the most, if your price of your ticket was in this range here, which is the highest range, you had a higher chance of survival, which is intuitive and makes sense, right? Right. Next, we're going to convert these bands into numbers, like we did with age. So the lower band has a value of 1, the higher band has a value of 3. And we can drop the fair band. Okay, next we're going to go into cabin. So the cabin column has these values. It's a number and some digit afterwards, some digits. We are going to parse off the number, so we're just left with the number. Okay, we are just left with the number here, and then we're going to plot this. So you can see here that there is some type of distribution here for each of the cabin types. But it looks pretty same between whether you survive or not, right? It's if you were in like, it seems like if you're in B, C, in that range, you tend to have a higher survival rate than if you were in, say, like T. But it's pretty similar across both. But there is obviously more passengers we have for these than for the other lower values. Okay. Next, we'll be checking. So one thing to note is that there is a lot of null values for the cabin type. There's 687, and we only have 891 values. So what that means is it's probably not a very good column to use because there's so many missing values. So we're going to go ahead and just drop our cabin type. And then we can quickly check. This is what our data looks like now after we've done the dropping. So we're gradually working and cleaning up. The last one is ticket, so we're going to work with ticket next. Ticket, we can look at the first 20 values in ticket. It's a bunch of random numbers pretty much and letters, so we can pretty much drop that if it's not useful. And now this is our final data set here. We are pretty much done with pre-processing. We don't need to do any more normalization because all these values we've kind of inputted ourselves. So it's, we know what the range is, we know that they're going to be good, and they don't have these really great outliers or any missing values anymore. We can check our test set, our training set, and it looks like everything is pretty clean and ready to go. And then we can just do a quick sanity check and check for correlation. Generally, when you're building types of models, you don't want features that are all correlated together. So we're going to do a quick check. And it seems like, there's not too many that are correlated. Obviously with itself, the value would be correlated, but generally there is low correlation. Something like miss and being female would have a high correlation. That makes sense. Age and class, that should be correlated because they just built up a class, but again, it's not too high, so it's all right. So we have, this is a quick way to check to see if things are correlated, but it looks pretty good there. So that's it for the cleaning preparation. Our data set, as you saw, is ready to go. In our next video, we will be going ahead and building the machine learning models.